Okay, maybe this is more clear. Is it good? The sound?
Yes,
Yeah,
Yes, better, sir.
better, yeah.
very better. Yes.
And way cheaper than that kind of speaker. This is crazy. Okay, let's just get started. What time is it? Yeah, it is already 11:20. So, okay, this should be talking English, right? Okay. Yeah, welcome. We are going to have a course in analysis and design of algorithm. Okay. Maybe I can have a brief introduction to myself. Okay. There's a lot of chat here. This laptop is good, right? Yeah, so this course is going to discuss about analysis and design of algorithm. Oh yeah, I should introduce myself first. My name is Wawan. You can just call me Wawan. My full name is kind of difficult. You can just see my full name in Binus Maya. And I'm a researcher in Binus University, uh, especially in artificial intelligence actually. So maybe it is not kind of like uh, directly used the design and analysis of algorithm in artificial intelligence, but it is actually kind of useful for me to understand about how to analyze the algorithm in order to create a better artificial intelligence algorithm. And so, well, you are communicating with Bahasa Indonesia a lot. This isn't going to be a global class, I think. But yeah, let's just have some, yeah. It's okay if you want to chat in Indonesia, but I supposed to communicate with you in English. So, okay. Okay. Next, I will talk brief. Oh. Why did you use something like Haya Namo Buddhaya Sadhu Namaste? Well, I'm actually a Buddhist, so I know some of the words Namo Buddhaya and Sadhu. Okay. This course is, I think, is an important course that you need to master for you to be a good programmer in the future, because yeah, I will show you some a video that kind of like give you an illustration of why this course is important. Because I think that not what I think, it is actually true. The If you can understand the core of this course, you will have a very important skill that that is needed, uh, critically needed in industry currently, to optimize, to have a better program, to have a faster program. Because this is kind of like insider information actually from ticket.com. Yeah, it happened that one of the lecturer in Binus University is now technical leading in ticket.com, and he find that just by using basic of analysis and design of algorithm in this course, they can deliver a significantly better program to handle more and more customer in their in the ticket.com platform. Ah, I just said the brand. It's okay. And yeah, because of that, not in maybe in Indonesia, a lot of startup doing that, but especially in big industry like Google, Facebook, or Amazon, or Apple, you are going to be interviewed by using a question that is kind of like if you know competitive programming, the question will be something like that. And well, if you can understand about the core concept of this course, you will find that it is kind of easy actually, not really that hard to um, answer those questions. And yeah, just to give you some illustration, I will show you some videos, and not some, a video. Yeah, for more example, you can just search in YouTube with the keywords of programming interview. Okay, let me share the screen. You can find some of the videos that is related to this course by just searching in YouTube programming interview, but I want to show you especially this, where is it? Okay, this video, because it will be more encouraging if you know that what you will learn in this course will be can be applied to the industry, even in Google. So let's just watch this. The sound should not show them. Where is it?
Hi, I'm Edgar, and I'm a software engineer at Google.
Hi, I'm Becky, and I'm a software engineer at Google. So, Edgar, the question I'm going to give you today is, I'm going to give you a collection of numbers, and I need you to...
Is it too loud?
Yes.
So
It's kind of erratic.
See,
Video semua. Oh, okay. Oh. Okay.
iseng Alvin.
Sorry if it is too loud. lower the sound.
You take this collection of
Discontinued.
numbers and find a matching pair that is equal to a sum that I give you as well.
Okay.
So for example, the collection of numbers could be
Oh, someone just asked me to ask all of you to turn on your video. I'm not sure. Maybe this is a new protocol, and I have to wear mask also. I'm not sure why, because I'm alone in this room. Why should I wear that? But yeah, it's okay. Let's just everyone who has the camera can turn on their video. Okay, sure. Let's continue the video.
Hi, I'm Edgar, and I'm a software engineer at Google.
Hi, I'm Becky, and I'm a software engineer at Google. So, Edgar, the question I'm going to give you today is I'm going to give you a collection of numbers, and I need you to take this collection of numbers and find a matching pair that is equal to a sum that I give you as well.
Okay.
So, for example, the collection of numbers could be 1, 2, 3, and 9. And the sum that I'm looking for is 8.
Okay.
And then another example, just for another set of numbers, could be a 1, a 2, a 4, and a 4. And then again, the sum that I'm looking for is 8.
So in this case, I guess what I'm trying to figure out is you're looking for a pair of numbers that add up to 8.
Yes.
Right. So in this case, there isn't a pair of numbers that add up to 8.
That is true in
Okay.
this example.
And in this case, it is because the 4 and 4 add up to 8.
Correct.
Okay. So
Yes.
this would be like no, and this is like a yes. Okay.
Yes, you ultimately have to tell me if the pair exists.
Okay, so how are these numbers given? Can I assume that they're like in memory, an array or something?
Yeah, they're in memory. You can go with an array. You can also assume that they're ordered in descending order.
Okay. Oh, interesting. Okay. So how about repeating elements? Can I assume that there will be, like for instance here, what if I didn't have that 4? Could I use like the 4 and the 4 to get that 8?
You can't repeat the same element at the same index twice, but certainly the same number may appear twice, like
Okay.
you saw in the
Okay,
other
so
course.
like that would be a yes. How about these numbers? Are they integers or are they floating point or?
You can assume they'll always be integers.
Okay, negatives, positives.
Negatives could happen.
Okay, cool. So, well, the simplest solution, of course, is just comparing every single possible pair. So I could just have 2 for loops, one scanning the whole thing, and then the second one starting from, let's say you have the I loop and then the J loop starting from I plus 1 so that I don't repeat the same value, and just testing all of them if the sum is equal to the target sum. I mean, that's obviously not very efficient, but that would be like a way to solve it.
That would work. It certainly would be time consuming, I think, as far as
Yes.
obstacles is concerned. So is there any kind of example that could be a little bit fast?
Yeah, I think that would be quadratic, so better than quadratic.
Okay, I will stop the video first just to make a note about this video. you already see that they are analyzing some of a problem. And the first solution that was proposed by the guy is something like just brute forcing all of the number and find whether the pair can sum to 8. And you can see that they already understand that this is not going to be a good algorithm. This is going to be very slow, they said. And one of the term that you need to take a note here, that they say that that would be quadratic. Yeah. For now, you can just take a note that this is an important word, an important term. We will go back to this term a lot, and not really in quadratic we said, but maybe something like O(n) squared or something like that. But just take a note that you will understand how they can analyze this as something like a bad program, a slow program, and find a new solution on for this problem that will be faster. Yeah, some of you really understand. Already understand about the complexity, I think. Yeah, true. From Alphonse that what they mean quadratic is O(n) squared. Yeah, let's continue the video.
Well, since it's sorted, so okay, I guess I need to figure out, when I have a number, what I'm looking for is if there's another number that sums to 8. So if I have a 1, what I need to figure out is if there's a 7 somewhere in the array. And if that's the case, if it's sorted, then I can just do binary search. I guess if I go here and I binary search for a 7, then I go here and I binary search for a 6, which is the complement of that. And when I go here, I binary search for a 5, and in the end, I just don't do anything. And so in this case, I would solve it like that. So that's a bit better than quadratic. I guess binary search is a log algorithm in a sorted list.
Also a good answer.
Okay, this is the second term that is also will be frequently encountered in this course. What he said about log algorithm. We can see that he just said the quadratic program that he was designed before is now can be outperformed. He can design a new algorithm that is faster using the binary search that he said, and it is a log algorithm. Yeah, you can take a note on the term log. This is also an important term that we will going to discuss a lot in this course. Let's continue.
Algorithm in a sorted list.
Also a good answer.
Okay.
But still kind of slow.
Okay.
So what if you took a look at, instead of going a binary search, which is unidirectional, what if you started with a pair of numbers to begin with?
Okay.
And then worked your way sort of inward from there?
Let's see. So if okay, let me try to bound this thing. So the largest possible sum, I guess, would be the last two values.
That would be the largest possible sum,
and
yes.
The smallest possible sum would be the two smallest, right? So anything in between. Okay, so the range of the possible values is that, right? So there's nothing that is probably small. There's nothing that can be smaller than this value.
Right.
There's nothing that can be larger than that value.
You have somewhere to move from.
That's okay. So if this sum is 10 in this case, it's too large. So I need to find a smaller sum. So I could just sort of move this one over here. And if that is too small now, then I need to move that one over there. Okay, so I think I can just do it with that in a linear solution. Just moving at each iteration, I either move the high one lower if the high one.
Okay, this is the last term that I will highlight. He just said about something like linear solution. And this is also a term that we are going to use a lot in this course. And basically, from now, even if you don't understand about this, why that is called quadratic, log, and linear, but you can already grasp that the first algorithm is better. No, the first algorithm is the worst. The second one is better than the first one. The third one is better. Here means faster than the second one. And you already know also that they call the first algorithm is quadratic. The second algorithm is log. And the third one is, he just said, linear solution. This is a linear algorithm, he means. So basically, you can see that in a problem, you can tackle this problem with a lot of type of algorithm. You can propose anything and you can find the exact same solution. But not all solution is have the same speed. You can propose an algorithm that is way slower, and also you can propose an algorithm that is way faster than the previous one. So by mastering this course, you can, well, this is actually kind of big, but by just mastering this course, you can already did what the guy did. So it is not kind of difficult to analyze what he analyzed in the video. It is quite basic actually. So by mastering this course, I hope this is encouraging you. You can do cool things like this guy, and maybe this is also a basic that you need to understand in order to pass an interview, a programming interview. Maybe in Indonesia, in startups, technology startups, you will find that you will be interviewed with this kind of question. And not only for interview, when you become a programmer, you will also needs to understand this in order to bring a solution, a faster solution to the industry. Because if you just naively apply a program, a code, an algorithm, you can cost a lot of to the industry because just because your algorithm is too slow. Well, you can just see the example like when you encounter a slow program like yeah, maybe in the early days of startups, you may find that the website is going down just because they start up to gain some popularity and more users join the e-commerce. Well, I have an example actually for this. I'm since the pandemic, starting, I'm using an application to order to shop online from a supermarket called Happy Fresh, if you know. At the start of the pandemic, they are going like down 2 or 3 times in a day, just maybe because the program was not well designed with with an optimal solution like what we will to learn. But yeah, they are starting to catch up a week after that. Hopefully, maybe because they hire a good programmer to solve the solution, to solve the issue of the website is going down. Yeah, let's just continue the video a little. Maybe you are kind of like want to see the solution that is offered by this guy.
Lower if my pair is too large, and I move my lower higher if my pair is too small. And I end whenever I either find two, like in this case, I either find a pair that adds up to 8, or whenever they cross. So at every point I'm moving one of them, so they would have to at least cross. And I move exactly 1, so that means that it's linear. Yeah, so that would be a way of solving that problem.
And how does it make that faster than a binary search?
Okay, so in the binary search case, I was doing log for finding, but I had to repeat that for every element, so that was an n log n solution. In this case, I just need to do that scanning the one time, so it's a linear solution, so that's faster.
Right, okay. So before, maybe we could get to coding it, but before we do that, maybe you could explain, so you explained it in a non-working.
Okay, we are not going to cover all of this video for this course. You can continue to watch it in YouTube. Yeah, you can just find the video by searching programming interview in YouTube. Okay, now we are going to start the session for algorithm design and analysis. Or okay, maybe I can just show you the syllabus of this course so you can understand what you will learn in this course for the next maybe about 26 sessions. It's so slow. Is it? Okay. So what I want to highlight about this syllabus, yeah, you will get 26 sessions for this course. But I want to highlight that what you really need to understand for this course, if you can just take a concept from this course, it will be the concept from the session 3 and 4. So pay attention to this session. So yeah, it's going to be the next week, because this is the very core of this session. And I'm going to also, this concept is called as computational complexity. Yeah, keep in mind that when you learn about this course, mainly you will learn about computational complexity. Yeah, maybe just to make it clear, you will learn about what is called as computational complexity. What I chat. And here is the next session is actually something like explaining examples of how to use computational complexity to design a new solution, a faster solution, by using different kind of techniques like binary tree, binary search. Yeah, actually, in the last video, you find that the second algorithm that was proposed by the guy is using binary search. And also you will learn about a technique called divide and conquer, greedy methods, dynamic programming for various problems, Huffman code, graph coloring, and so on. Yeah, this is what you learn in this semester for analysis and design of algorithm. Oh, it is algorithm design and analysis, okay. But I'm going to stress this a lot. What you actually need to learn about this course is computational complexity. So keep in mind that you have to master this no matter what. Because if you fail to master this, you're not going to be a good programmer. You're not going to be an effective programmer, and it will bring disaster actually to the industry that will employ you. So keep in mind to master this. Okay. This course actually is integrated with a competition called as INC. I'm not sure if the global class is also required to enter this competition. Yeah, the competition named Indonesia National Contest, or INC, and it is going to be 20%. So your performance on this competition will be 20% of your final score. But it is not going to be like very difficult, because the competition is going to have problem something like this. The type of algorithm that you already familiar with in the algorithm course. something like this. You will find a story, a problem, and you will be explained the input and output, sample input and output, something like this. And the problem isn't going to be very difficult, not all of them difficult. As you can see, for the first question, the question A, this is the performance of all teams last year. You can see that this problem A is actually very easy. The green one means that the team have solved the question. And you can see that almost all of the participants can solve this, and you will find that there is a lot of teams from Bina Nusantara University. This is your seniors doing the competition, like you will, and you can already find that this 3 question it's not actually difficult. A lot of teams from Binus, your seniors that is also taking this class, can solve the problem very well. Not really that difficult, and by just solving this question, you will get about 70. So it is not going to be like make your life difficult. Just make sure that you enter the competition and do the best you can. This is a competition that will be every students in this course, algorithm design and analysis, needs to enter this. This is the definition of the contest. Yeah, you can find this description on the slides that you can download from Binus Maya. And you can use C or C++ or Java for this contest. And yeah, you can find more on the information in this link, or if you want to have some exercise to study what type of problem that you can solve similar to the competition, you can find it on this link. Well, I'm not actually know the details about this competition for this year, because maybe the administration is going to be different from the last year. So yeah, I will keep you up to date with the information if I have the information. And maybe just to smooth our communication, I will form a Microsoft Teams group so that you can chat to me directly at the group. If you have, if we have to sort of share information or just discussing about this course about computational complexity in general. After this class, I will form the group and send the code to you in the group chat, in the Zoom chat. Oh, Discord. Well, I'm not really, maybe not a millennial, so I don't use Discord a lot. I'm an old school, maybe. We can just use Teams. Okay, so actually we don't need to discuss a lot about the first slide. This is just definition of algorithms. I believe that you already understand about this pseudocode. Yeah, you don't ask. If you pass the algorithm course, of course you know about the pseudocode. So maybe we will just skip the algorithm pseudocode things. There is kind of okay. Before we discuss some of the things that is important in this slide, I will give you a brief introduction about computational complexity. This is actually a material for session 3, but I will just give you a brief introduction because if we want to discuss for the second slide, that is with the topic of what it is called, mathematical induction. It will be beneficial if you understand about computational complexity, at least in a nutshell. Okay, let's consider an algorithm like this. I'm going to just write in pseudocode. This is not actually a C++ code. For I equals, let's just say from 1 to, well, I think I need to define something. Let's have it with a flipbook. Okay, let's define an integer. Oh, that's kind of like infinite. Integer n equals, let's define it like 5. And we will have a loop for I from 1 to n. Yeah, kind of professional like, but I cannot really draw. This is just for teaching. Okay, so if we see for like this, I could say that this is going to loop from 1 and then 2. Maybe I can just do something so that it will be clear. See, I want to print I. Well, actually, if you see my pseudocode, it is more like a Python code because I'm more familiar with Python. Okay. For this is I, the 1 to n, print I. So this code will going to print something like 1, 2, 3, 4, 5. Okay, something like that. This is something that we will call as an algorithm that has computational complexity. Maybe we can just drop something. Sometimes we don't really say about the computational. We just say the complexity. So for this algorithm, it will have a complexity of big O n. Okay. Why is this big O n? It means that if we increase the number of n, the value of n. Let's see if I change this to 6. Then you will find the algorithm will loop for 6 times. Okay. If we change this to 7, it will loop for 7 times. If I change this to 8, it will loop 8 times. So the speed of this algorithm is dependent on this variable n. So we could say that the speed of this algorithm, or in other words, complexity of this algorithm is n. Means that if we input 8, it will loop 8 times. And this is what is called as linear by the guy in the video. We will discuss a lot about this, why this is called as linear in the next week. I think you are focusing on the wrong things. Yeah, this is Wacom. Okay, so let's have the next example. What if instead of just 1, integer n equals maybe, yeah, let's have 5. We are going to have an algorithm like this for I equals 1 to n also, but we will have for j equals 1, sorry. To n also. Yeah. This is like, okay. This is doing something. It doesn't matter what. Okay. For this algorithm, you can see that for its I, when I equals 1, we will loop for j of from 1 to n. So for I equals 1, we will loop j equals 1, and then j equals 2 until j equals 3, equals 5. And we are going to loop this for 5 times also, from I equals 1 to I equals 5. It is not a good I. So you can see that the total loop for this algorithm will be something like 5 times 5, 25 times. And because we divide the n is 5, you can quickly see that this is going to be something like n by n for the complexity. So in conclusion, the complexity of this algorithm should be O n by n or n square. Yeah, this is same thing. And you will quickly see that this algorithm just with the same number of n, 5, it loops significantly larger, 25 times compared to the first one, just 5 times. Yeah, although these two algorithm does not output the same output, but imagine that these two algorithms, this one and the first one, output the same things. Of course, you don't want to use this algorithm. You want to use this algorithm because it will achieve the same thing with just 5 loops over this algorithm that use 25 loops. And now you can already see why we need to have a language like this to represent an algorithm. This is ON, linear, and this is ON squared. This is what is called as the guy in the last video as quadratic. Yeah, so by just quickly see the algorithm, you can find that, okay, this is going to have a 4, a nested 4. So this is going to be quadratic. Because of that, the guy in the last video can quickly see his first solution is not really that good. It is quadratic. It is going to have 25 loops instead of 5 loops. And by designing an algorithm that can achieve the same thing that is linear, they can the algorithm can run for just 5 loops instead of 25 loops, and get the exactly same same output. This is why it is important for you to understand about computational complexity, how we express it in a language called as Big O, so that you can quickly communicate to other programmers that you can just say, oh, I have found a new algorithm that is linear, and we can replace this, so the quadratic program that is already deployed in the server, something like that. Okay, why do I need to give you a brief introduction about this? Is because okay, let's have an algorithm like this, maybe integer n equals 5, and then there is 4 for 1 to n, and then for j equals I to, let me see my cheat sheet. This is a good slide actually provided by the technical lead of ticket.com that I said before, but it is unfortunately in Bahasa Indonesia, and I'm not sure if I can share this, but I will try to explain the theory in this slide. Okay, let's get this. I equals n. Okay, from I to n. Okay. Yeah. Let's consider an algorithm like this. Now, how can you determine what is the complexity of this algorithm? Let's try to break the code, the loop one by one. What if we have for I equals 1, how many times do we need to loop? For I equals 1, that means for we will loop j for j equals, this is I, not 1, yeah, from 1 to n to 5. Let's just use 5 here. So it means that it will loop 5 times. Yeah, for j. Let's see what if we have I equals 2 for the next loop of the I. It means that j is going to be looped from 2, because I equals 2, to 5. So it will be 4 times. Let's just erase the times. That's annoying. And then for I equals 3, it means that this is going to be 3 to 5. That means it will be looped 3 times, and then yeah, and so on. 4 to 5 and 5 to 5. This is 2 times and then 1 times. So you can see that this is not going to be something like O(n) squared anymore, because if this is O(n) squared, it will be something like 5. This is 5, this is 5, 5, 5. But this is not 5, 4, this is 3, 2, 1. It's going down. So maybe n squared is not actually a good representation anymore. So how do we find what is the complexity of this loop pattern? This is why we need to understand about the concept of mathematics. Yeah, you are going to see a lot of mathematics. Just be brave. What is called as series. So yeah, fortunately in this course you will just need these 2 series for the whole course. But yeah, in the real world, maybe you need to be more familiar with another type of series. But at least in this course, you can just remember these 2. the arithmetic series and harmonic series, and you see that I cannot. Okay, you see that some guys, a mathematician, already proved that this is true. Let me just highlight it. Okay, let's just erase this. Okay. Okay. It has been proved that this pattern, 1 plus 2 plus 3 plus 4 until plus n, is equals to this, n times n plus 1 per 2. So by just you having familiar with this pattern called arithmetic series, you can already understand that this pattern is arithmetic series. So you can just take this term here, that 1 plus 2 plus 3 plus 4 plus 5 and so on equals to n times n plus 1 per 2. So the computational complexity of this algorithm should be about, or not about, it is exactly n times n plus 1 per 2 divided by 2. Okay. So instead of n squared, we have this complexity. Well, actually, if you see the slide here that said it is theta n squared. Well, this is kind of true, but you can just disregard this for now because it will be confusing if we don't speak about in detail about computational complexity in that will be going to be covered in the next week. Okay, so now what I want you to understand is that this is an important mathematical concept in to model about computational complexity. And mathematical induction is mathematics that will enable you to prove something like this. If whether 1 plus 2 plus 3 plus 4 equals this. So whenever you counter a new type of series, just for example, maybe if you encounter a loop that looks like this, 5 plus 8 plus 11 and so on, and you don't know what is the pattern of this series, but maybe you can guess, maybe it is kind of like k plus 3k plus 7 plus 2, but you are not sure. This is how you prove it. Mathematical induction. Well, the theory of mathematical induction is not going to be used a lot in this course. Actually, it is just introduced in this session, and it will not going to be used in the next sessions. But I find that it is important for you to at least know about this mathematical induction, so that in the future you will understand that this proves this equation that 1 plus 2 plus 3 plus 4 and so on equals this. It's not really difficult to be proved. You can prove it by yourself by using mathematical induction. If by chance you don't remember about mathematical induction in this course, at least you just remember about the term mathematical induction. So in the future, you can just Google it. Okay. Let's have a quick explanation about the mathematical induction. Oh, not this slide. Okay. Let's just go directly to the to the example so that you can quickly understand what is mathematical induction. We are going to prove that really that.
All right, welcome.
Let me just have a writing here. We want to prove that whether it is truly 1 plus 2 plus 3 plus 4 plus 5 plus and so on plus n is really equals to n times n plus 1 divided by 2. For this example, we are going to prove this. Okay, this is the simplest term for something like 1 plus 2 plus 3 plus 4, but if you are a mathematician, you will use this term more frequently. Yeah, it is, if you remember your mathematics in high school, sigma I from I equals 1 to n. So it means that I equals 1. This is 1. And sigma means that repeated sum. So this is kind of like looping what I equals 1 to n, and then I equals 2 plus 2, I equals 3 plus 3, and goes to I equals n. I just want to have a quick recap about this because I find that several of the students don't really remember about this, even though this is kind of like a high school mathematics. Okay, let's try to prove this. Oh, good thing there is one of you that remember this. Okay. Let's try to prove this term. Okay, let's use sigma I from I equals n to a equals 1 to n. Maybe I can just use the longer term just to make it clear. We want to prove 1 plus 2 plus 3 plus 4 plus 5 up to plus. I will use k here instead of n, just to follow the terms that is used in here in the slide. Let's prove whether this is truly equals to k times k plus 1 divided by 2. The first thing we need to prove is if k equals 1, is it true? If by any chance k equals 1 already false, that means that this pattern is not going to be equals this, right? So let's find out if we substitute 1 times 1 plus 1 per divided by 2 means 2 divided by 2, 1. Okay, the first term is 1, so this is true. And this is actually the first step that is explained in the slide about mathematical induction. So this is the first step, proof that if we substitute it with 1, it is actually true. And we already did that. Now the second step that we are going to execute is proof if we have the number, some variable number n, if n is true, then n plus 1 is true. It means something like this. Let's just use this. Okay, imagine that if we have the this PP means that the formula, if we substitute n with 1, it is true. Then if the second one is true, then we can say that, hey, 1 is true. What if P2? Because of the second one, we have proved that if for any numbers of n plus 1 is also true. That means that 1 is true, 1 plus 1 is true, 2 is true. So this is true. And then what if P3? We already know that P2 is already true, so 2 plus 1 is also true. So this is also true. How about P4? P3 is already true. 3 plus 1, it must be true. So it is also true, and so on. So by just proving this term, we can say that for any numbers, the equation of this is going to be true. Whatever number you enter to this, you input to this, is going to be true. So that is the idea of mathematical induction. We want to prove this second term. And also, provided this first term is also true for the baseline. And let's see in action how we did this. Now, yeah, this is the first step. Okay. The second step, we want to have if K is true, then K plus 1 is true. So to have to prove this, we will do something like this. Let's see. Let's erase this. We will try to add K plus 1 in the term. Okay. It shouldn't be matter, right? Because K is just some random, not random, variable number. So it means that this term is going to be like K plus 1 here times K plus 1 here plus 1 divided by 2. Let me have, okay. Now you can see where this is coming from, K plus 1. We just substitute the equation, this equation n plus 1 divided by 2, by substituting this n with K plus 1. So we have this term, K plus 1, K plus 1 plus 1, and then 2 divided by 2. And now we want to believe that this term is true. This term equals this is true. K plus 1 divided by 2. This is true. We want to believe this true. So it means that we want to prove whether this term, yeah, this K plus 1 comes from this, is equals to this K plus 1, K plus 1 plus 1 divided by 2. Okay, so this is our task now, to prove that this term is actually equals. Let's have it in another sheet. K plus 1 divided by 2 plus K plus 1 equals to K plus 1 K plus 1 plus 1 divided by 2. Okay, we want to prove this. And I think for an easier writing, I'm going to switch the right term and left hand term So it is going to be like this. K plus 1, K plus 1 plus 1 divided by 2 equals to K plus 1 divided by 2 times, not times, plus K plus 1.
One.
Okay.
One.
And we are going to calculate this to
Drawing
have
tablet yang bagus apa ya?
exact same form like this.
Drawing tablet
So let's see what if we
yang murah dan bagus. Ya.
We have a same denominator here,
Hah?
K plus 1 divided by 2 plus 2
1,2.
K plus 1 divided by
Ya paling murah.
2. So here it will be,
Wow. 420.
we will count this
Huyon. 430 apa 420?
K squared plus K divided by 2 plus
Iya tahu.
2K.
Ini juga
We will
430 P.
calculate this
What the fuck?
plus 2 divided by 2.
Ini cuma kayak buat osu bisa gitu
Okay.
maksudnya kan.
Let's have it in the next.
Bagusan 420 apa 430?
So the last time we have this K plus K,
Tombolnya buat
K squared plus K. Yeah, let's just continue this.
Bisa.
Plus 2K plus 2
Ya. Oke.
divided by 2. Okay, something like this. Next, we will have it K squared plus 3K
Iya.
plus
Gue
2
lihat 420 plus 430 ada tombol 4 biji di atas ya.
And now by factorizing this term,
Ada 4 tombol kayak 4 tombol.
we can have it K plus 1. Yeah.
Di mana?
K plus 2.
Hah?
Divided by 2.
Ngajar
It
apa?
should be like this, right? Let's have the formula. If I remember the formula correctly, it should be.
Gue pengen ini sih buat belajar juga sih ini.
K squared minus 4.4.
Tablet kalau tab itu nggak bisa dikonek jadi ini ya, jadi drawing tablet ya.
Plus minus.
Tab Samsung.
Something like this. I'm not sure.
Iya sih. Bukan mirror kan, tapi kan cuma kayak ke save bisa.
I just remember the formula.
Ya, itu dia.
Let's just Google it. This is
Masa
how a
itu nggak
good
bisa di mirror
programmer
kan?
works.
Oh misalnya ini kayak
Google.
dibikin ini. Damn. Gue beli kali. Iya gue beli lah. Nggak tahu gue beli. Gede nggak sih dia? Kecil nggak sih? Sumpah, gue kecil banget aja.
Minus B plus minus. Oh, sorry. 2A. Okay.
Sabar, itu
Like
jatuhnya tuh kayak satu layar full gitu, apa lu bisa kayak gedein layar?
Minus B plus minus.
Oh bisa kayak lu ini lagi ya, kayak buat bisa lu. Oh dia
B squared.
ini tuh dia tuh yang kotak yang buat drawingnya itu sesuai dengan apa yang ada di monitor kan ya, kan fase. Oh oke.
Divided by 2A. Yeah, something like this. So we can just input the number
Battery free what? No charging.
here to find the
Kok bisa free?
factor.
Oh dia pakai statis ya?
Means that 3 minus 3 plus minus
Belanjaan 75.000,
B 3
15.000.
square minus
Beli.
4 AC. Oh,
Ah,
sorry,
beli
sorry.
mana? Oke.
4 times A equals 1 here times C equals 2. And this is your math high school, 2 times 1. So it should be something like this is 9, 9 minus 8, this is 1. So minus 3 plus minus 1 divided by 2. It is so it is minus 2 and minus 1. Okay, so this is x of k equals minus 1 and minus 2. So it means that the term should be k equals minus 1, minus 2, or minus 1. So it means that the factorization should be k plus 2 and k plus 1. Yeah. Okay, I'm not going to cover a lot about why it is going to here. It is just your factorization in your high school. And so we have this term, and we can quickly see that we can form this equation, this formula to be like this: k plus 1 divided by 2. And we will already see that this is the same formula like the first left-hand term, k plus 1 plus 1 divided by 2, k plus 1 plus 1 divided by 2. That means if we can reach the same form compared to the left-hand term, then we can already say that we prove this is correct. This is true. That 1 plus 2 plus 3 plus 4 plus 5 until plus k equals to, it means, what I mean is we already proved that this term 1 plus 1 plus 2 plus 3 and so on is equals to n times n plus 1 plus divided by 2. You see that the mathematics is not really that difficult. It's just kind of like high school mathematics. And actually, I believe that mathematical induction was taught in high school. I'm not sure. So that's basically a tool, a mathematical tool for you. This mathematical induction to prove whether a series is true or not, the pattern. And yeah, also maybe you can just be familiar with this identities. Mostly this is logarithm identities because a lot of our complexity is going to be something like log. We need to express this as a logarithm of n or log n. That's the why the guy in the last video said something like binary search have a complexity of log algorithm. It means that what he actually means is log algorithm means an algorithm that have complexity of all log n. That this is what he means. And we are going to cover a lot of algorithms that has this kind of complexity. And okay, what time is it? Okay, the last thing that I want to deliver in this course is about the about recursive. But I believe that you already understand about what is recursive function in the last algorithm course. What I want to show you is that you can express a loop in using recursive because and because of that you what I mean is that you need to see it when you design an algorithm that use recursive function. You need to understand that this is going to be a loop, and because this is going to be a loop, you need to understand what is the complexity of this recursive function. So let's see. I just have something like function. Let's have. Let's have a function called as func. They have n. Okay. Okay. And in the function, it will be terminated. I will going to have it just like terminated if n equals 1, else n equals 0, else print n. Okay, so if you have this recursive function, you can quickly see that if we input n equals 5, first it will print 5 here, print 5. Okay, it should be something like n equals, they will call function, again, function n minus 1, something like this. Okay. So this is going to be, yeah. So else these two command will be executed, print n, and then do call again the function, but now we are having it n minus 1. Let's move this. Okay. Now we can see that in the first call, it will print 5, and then it is called again with n minus 1. So now n is equals 4, and the function is executed again. It is not terminated because it is not n equals 0. Print again n 4, n equals and then call the function again, function n minus 1. And you can quickly now see that it will print 5, 4, 3, 2, 1 plus the 2. Okay, it will print something like this, and you can express this with different algorithm, with looping, with just 4, 4, I equals 5 to 1, print I. It is the same thing. So because of that, this recursive function, we can call this as an algorithm that has ON. And yeah, because it is, this algorithm also print the same thing for 5 times. It is also ON. So this is exactly the same algorithm, but one is using recursive, but one is using for loop. Now, what I want to stress this in this example is that whenever you encounter a recursive function, please keep in mind that this function has its own complexity, like this for loop. And you need to actually go through the logics to find out what is the complexity of this recursive function. Okay, this is the last thing that I want to deliver for this course. Okay, if you have any question, you can just type it on Zoom chat, or you can also speak. For at the meantime, I will form the Teams group. Is stack faster than recursion? It is. I'm not sure if stack and recursion can be compared apple to apple. Let me just give you a quick. So a stack is something like this, a concept that using an array to store data for one, we will maybe place it here, and then if we have the next two, we will place here, and maybe not two, maybe we are going to have one again, we will place here. But when we have this out, when we want to pop the data from this, we will maybe we can just have it 3. We will have it 3 first, and then the next 2, the next one. And now you see that this is a data structure, and recursion is something like having a function that that can call itself. I'm not sure what is your question actually. Could you explain it? Maybe if I'm just guessing, what you mean is stack in using loop faster than recursive. So I mean that you apply stack using recursive versus using loop. In general, it will be faster if you are just using loop than recursion. I will go back into this about why recursion is having more complexity in general than loop, the loop version. it is not the time complexity actually, the memory, the space complexity, but we are not going to discuss it a lot today. I will going back to that in the next week. Okay, I hope that what I mean is correct. So let's have the Teams group. Okay, in the chat, that's the code to join the group Teams for us to discuss about this analysis and algorithm design and analysis. It is a group for the general class. I'm not sure what is the term in Indonesia kelas besar, but for the next week, it is going to be taught by different lecturer for some of you. For the smaller class, yeah, but some of you will be still taught by me. For the smaller class, maybe I can, maybe you can just discuss about the, it's going to be not too big good. Okay, for the smaller class, I will have a separate group if it is necessary. But for now, we are going to discuss just in the group for the bigger class. Okay, if there is no other question, I will end this session in 5 minutes. So please make sure that you copy the code and join the group. I'm not sure whether the video will be shared or not, because the one who records this is the account LS13 Alam Sutra host. So the video will be stored by them. Yeah, you can maybe chat to LSC, not LSC, for the student one. Yeah, chat to the student customer service SSC to ask whether you can have the video or not. Oh. Yeah, you can leave the Zoom if you already copy the code and join the group.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you so much, sir.
Thank you for the knowledge, sir.
Thank you, sir.
Yeah.
You, sir.
Thank you, sir.
Sir. Goodbye, sir.
Thank you, sir.